Welcome to this lesson on exothermic and endothermic reactions. In this presentation, we will explore the meaning of these reactions, their differences, examples, energy changes involved, and their applications in daily life. Every chemical reaction involves energy changes. This happens because bonds in reactants must be broken and new bonds in products must be formed. Depending on the balance between energy absorbed and energy released. Reactions can be exothermic or endothermic. An exothermic reaction is a chemical reaction that releases heat energy to its surroundings. This means that the environment around the reaction feels warmer as the temperature increases. Some common examples of exothermic reactions include the burning of fuels, neutralization of an acid with a base, respiration in living organisms, and even the explosion of fireworks. On the other hand, an endothermic reaction is a chemical reaction that absorbs heat energy from its surroundings. This makes the environment around the reaction feel cooler as the temperature decreases. Examples of endothermic reactions include photosynthesis, dissolving ammonium chloride in water, the thermal decomposition of limestone, and even the melting of ice. Let us compare exothermic and endothermic reactions. Exothermic reactions release heat, while endothermic reactions absorb heat. In exothermic reactions, the surroundings become warmer, but in endothermic reactions, the surroundings become cooler. Examples of exothermic reactions include combustion and respiration, while examples of endothermic reactions include photosynthesis and melting of ice. In an exothermic reaction, the energy profile diagram shows the reactants at a higher energy level than the products. The difference in energy is released to the surroundings. In an endothermic reaction, the energy profile diagram shows the reactants at a lower energy level than the products. This difference in energy is absorbed from the surroundings. We are given a reaction between the gases Q2 and R2 forming the product QR. The energy content of the reactants is 100 kilojoules. The activated complex has an energy of 210 kilojoules. The products have an energy of 54 kilojoules. Our tasks include drawing an energy profile, finding the activation energy, calculating the enthalpy change, writing the balanced equation, and deciding whether the reaction is exothermic or endothermic with a reason. To find the activation energy, first, list the two values you need. The energy of the activated complex is 210 kilojoules, and the energy of the reactants is 100 kilojoules. Next, find the activation energy by taking the peak energy of the activated complex and subtracting the reactant's energy. That gives 110 kilojoules as the activation energy for the forward reaction. Now calculate the enthalpy change using products' energy minus reactants' energy. Products have 54 kilojoules and reactants have 100 kilojoules, giving a change of negative 46 kilojoules. Write the balanced equation as Q2 gas plus R2 gas forming 2 moles of QR gas, shown with a reversible arrow. Because the enthalpy change is negative and the products sit lower in energy than the reactants, the reaction is exothermic. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time. Here are the remaining questions. Study and answer the questions. In summary, exothermic reactions release heat while endothermic reactions absorb heat. Energy profile diagrams help us visualize the changes in energy. We also saw that many of these reactions happen in daily life and in industrial processes. This concludes our lesson on exothermic and endothermic reactions. Thanks for watching. To deepen your understanding of any topic, explore our comprehensive resources, including revision notes, past questions, gamified quizzes, and workbooks. These tools are designed to help you master the concepts effectively and enjoyably.